Here, we're going to do integration, but we're not going to integrate trig functions. We're integrating these things that will give us a solution or resultant that is an inverse trig function. So that's why it's important to know the difference of that. We never are going to integrate inverse trig functions, but we're going to get a situation where we integrate some things that end up being inverse trig functions. All right, and here we have two examples of that, okay? And if I look at my formula sheet, it's pretty straightforward. It actually looks like this one, but I know that because of this negative here, that this is actually cos, so that that's the result of it plus c. And you can follow the formula all the way through and you'll get that result, okay? I'm not going to go into detail of how to explain it. This next one is pretty simple, it's just tan. I'm just going to rewrite it like this. All right, remember we can always pull a constant out to the front and get the same thing. So obviously I'm going to get 4 inverse tan x plus c. Now we've got to remember the plus c because it's not, the boundaries are not there. So we've got to make known the plus c. All right, let's keep going. Okay, so how do we do this one? Well, here we're going to start looking, so these ones were all ones, okay? Here we're going to start looking at these guys here, all right? Now this one looks like it's sine. It's positive, there's no negative there. So it looks exactly like this one. Now what is my a? Well, I need to rewrite it a bit, okay? I'm going to write as 2 squared minus x squared all dx. And now I can easily put it into my formula. So my a looks like it's clearly going to be 2 from this guy here. And my f of x is x, all right? So that's going to be here at the top. And then the derivative of x is just 1, so that's really good. So the answer of this one's going to be sine, it's the inverse sine of it, and it's going to be x over 2 plus c. And if you follow the formula all the way through, you should get there yourself as well. All right, what about the next one? Well, the next one I'm going to do a couple of things before I start following all the way through from the formula. I'm going to pull these 3 out the front because it makes it a lot easier. And then I'm going to go 3 plus x squared, all with respect to dx. Now I need to change a few things to get into that formula. I've got a squared and I've got that thing going on there. So I'm just going to keep that 3 at the front. I'm going to go 1 over square root of 3 squared, okay, because that gives me, this thing gives me this. So I'm just going to write it like that, plus, and then the function is x, and we'll do that all squared dx. Now I think I'm ready to answer my question. So it's going to be 3 times, what's 1 over a? 1 over root 3. Inverse tan, our f of x is x, and our a is root 3. And obviously, plus c. So let's fix that up a little bit more. It's going to be 3 over root 3, inverse tan, x over root 3 plus c. If you're really confused about this, I want you to really try follow this formula carefully, because it's just like I'm just using it, popping it into it, and we get our resultant answer. All right, let's do this one. Okay, so I'm going to do the same things as I've been doing in the previous examples, but I'm just going to fix a few things up. So my first line of working out, I'm going to go x over, I'm going to have to do something with that soon, but let's see how we go. And I'm going to go square root 3 squared minus, now I want to get something squared. See how here in the formula sheet it's squared? So I'm going to go x squared squared dx, okay? And I have that, okay? Now, that means my f of x is x squared. See, f of x, x squared. And I need the derivative on the top. So at the top of this, I need a 2. And to compensate, at the front, I'm going to put a half. Okay? Hopefully you're following my rationale. Now I think I'm ready to go and just pop everything into there. It looks clearly that it is going to be sine. Okay? So I'm going to go half. So bringing that half down the bottom. It looks like it's sine. So it's inverse sine. Now our f of x was x squared. And our a is 3 plus c. Done. Okay? Alright, I'm going to do the same with this one. I'm just going to fix it up a little bit. It looks like it's a little bit of a tan sort of thing. See here, we've got an a squared. So I'm going to fix it up so it looks a little bit more like it. We've got 2 squared plus. Now, this thing needs to be squared too. So if I use my index laws, it's going to get e to the x squared that. Oh, that works really well. Because I know that the derivative of e to the x is e to the x, so that works, okay? And I think I'm ready to go. So it's going to be 1 over a. What's our a? It's 2, so it's going to be half. Inverse tan, and our f of x is e to the x. So it's going to be e to the x over, what's our a? 2. And then we're done. Plus c. So hopefully it all makes sense. I'm pretty sure that's the end of that video. So any questions, please ask. But that's it. Peace out.